Welcome to the deep dive, where we try to cut through the noise and, zero in on the insights that really matter.
Glad to be here.
Today, we're jumping into artificial intelligence and machine learning. AI and ML, they're terms you hear everywhere, often used interchangeably.
Right, and that causes a lot of confusion. People tend to think AI is just one, single big intelligence.
Exactly. But our deep dive today, well, it shows it's much more complex than that. Think of it more like a huge toolkit.
A very sophisticated toolkit.
And machine learning, that's one of the sharpest, most adaptable tools in that kit. So our goal here is to unpack that relationship.
Understand how ML really became the powerhouse behind so much modern AI.
Yeah, and trace how that leads to, well, the really exciting stuff like generative AI. We're basing this on a guide covering AI and ML essentials.
And, getting this relationship right, AI versus ML and how ML uses data, it isn't just theory.
No, not at all.
It's actually pretty crucial. It helps you effectively contribute to AI work, maybe even lead some initiatives. It's vital for leveraging data properly.
Absolutely. And it helps you ask the right questions too, right? When someone proposes an AI solution, you can think, okay, is this the right approach for this problem?
Precisely.
So let's peel back those layers. We all interact with AI constantly. Your phone predicting text, streaming recommendations.
That's everywhere.
At its heart, AI means computer programs doing cognitive tasks, things we usually associate with, well, human thinking. But building these systems, there are basically two main ways designers go about it.
Two fundamental techniques.
First up, you've got rule-based techniques. These AI programs, they work on a really strict, predefined set of instructions, like a recipe, step-by-step.
Very rigid.
Yeah, like my old spam filter. It was classic rule-based. It saw urgent or bank transfer, boom, blocked. No thinking involved, just rules.
No nuance. If the rule fits, it
Yep.
acts.
Right. I remember it once blocked my actual bank statement because the subject line said urgent action required or something.
Yeah, that's rule-based for you. But that rigidity is good sometimes.
True. For things needing strict logic, like safety checks or really simple sorting, it works perfectly.
But the world isn't always that simple.
Exactly. What happens when things are messy, ambiguous? That's where the second approach, machine learning techniques, comes in.
This is where it gets really interesting.
Instead of coding every single rule these AI programs learn, they analyze patterns in data and then make their own decisions based on that learning.
So like your current spam filter.
Yeah. It's learned over time that, okay, maybe my colleague sends an email with a typo or uses a weird phrase, but it's probably not spam because I always mark their stuff as safe.
It adapts. It learns context, not just keywords.
That adaptability, that's the power of ML for complex real-world stuff. But I wonder, are there still cases where those old-school rule-based systems are actually better?
Oh, absolutely. Think about, say, financial systems or compliance checks. You need total certainty. You need to know exactly why a decision was made.
The audit trail.
Precisely. A rule-based system gives you that clear logic path. An ML model might be super accurate, but explaining why it decided something can be, well, much trickier. The black box problem sometimes.
Okay, that makes sense. Transparency versus flexibility.
Exactly.
Yeah.
So for things needing absolute clarity and unwavering consistency, rules still often have the edge. What's fascinating, though, is how these two approaches differ fundamentally.
Right. One follows orders, the other learns.
Yeah. Rule-based is predictable, great for rigid tasks. ML thrives on ambiguity, massive data, things you just can't write rules for.
And real-world AI often mixes them.
Very often. Use rules for the clear stuff, ML for the fuzzy stuff. It's a shift from telling the machine what to do to teaching it how to figure things out.
So that need for figuring things out, for adaptability, that's really ML's domain. It's not just a technique. It's like a whole subset of AI, right?
Exactly. A whole field focused on getting machines to learn from data, pushing past those rule-based limits.
Okay, and how these ML programs actually learn. That's the next fascinating bit. There are, what, 3 main ways they get trained?
3 core approaches, yeah, each suited to different kinds of tasks and data.
So the first one is supervised learning. This one feels pretty intuitive, maybe.
It's often the easiest to grasp, I think.
The ML program gets data that's already, labeled, so a bunch of photos, and each one is tagged cat or dog.
Right. The answer is provided during training.
The program learns the features, the patterns in the images that correspond to the label cat or dog. It's great when you have a specific output you're aiming for.
Like prediction.
Yeah, or like predictive text,
Yeah.
training it on millions of sentences where you know the correct next word. It learns to finish your sentences.
Supervised learning needs that supervision in the form of labeled data.
Okay, clear enough.
Yeah.
Then there's unsupervised learning. This sounds different.
It is. Completely different philosophy. Imagine giving someone a massive pile of unsorted rocks.
Yeah.
No labels. They just start looking, right? They see patterns. Okay, these are rough, these are shiny, these seem to group together naturally.
Finding structure without being told what the structure is.
Exactly. Unsupervised learning gives the ML program unlabeled data. Its job is just to find patterns, clusters, relationships within that data all by itself.
No predefined categories?
No. So this is how, say, a system might find hidden customer segments in purchase data or group medical images based on subtle similarities humans hadn't noticed.
Without needing every image pre-labeled by an expert, which could take forever.
Precisely. It discovers the inherent structure.
Got it. Supervised needs labels. Unsupervised finds patterns in unlabeled data. And the third one?
Reinforcement learning. Now, this one is really interesting. It's more like how we learn or how animals learn, trial and error.
Okay. How does that work for a program?
Well, the ML program operates in some kind of environment. It takes actions. If it makes a good choice, it gets a reward.
Yeah.
Bad choice, a penalty.
Learning from consequences.
Exactly. Yeah. It gradually figures out the best strategy to maximize its rewards over time. Think about training a robot arm to pick something up.
It misses, gets a penalty, adjusts, tries again.
Right. Adjusts its grip, angle, whatever. Gets it right. Gets a reward. Over many trials, it learns the optimal way.
Where is this used most?
Games are a classic example, learning to play chess or Go. But increasingly, it's used in things like conversational AI.
Like chatbots.
Yeah, the system tries different responses. Based on user feedback or designer input, it learns which replies are more helpful or engaging. It refines its conversational skills.
So it gets better through interaction.
That's the idea. It's constantly learning and adapting its strategy. And what's really important to understand is that AI designers don't just pick one of these and stick with it.
They mix and match.
Often, yes. If you look at the bigger picture, all three, supervised, unsupervised, reinforcement, the DT, they have their strengths, their weaknesses.
Depends on the problem. And the data.
Exactly. What kind of data do you have? How much? Labeled? Unlabeled? What are you trying to achieve? A robust AI system might use supervised learning for its core functions.
Like basic understanding.
Right. Then maybe unsupervised learning to spot new, unexpected patterns in the data.
Find things you didn't know to look for.
And then maybe reinforcement learning for the parts that need to adapt dynamically, like interacting with users. It's like building with different kinds of bricks. You choose the right brick for each part of the wall.
That makes sense. Building intelligence layer by layer.
Precisely.
And it's really this progress, this refinement across all three of those learning approaches.
Supervised, unsupervised reinforcement.
That has paved the way for what everyone's talking about now, generative AI.
Yeah, the big one.
This isn't just about analyzing or predicting anymore. This is AI that can actually, well, generate totally new content.
Text, images, code, music, you name it.
All from a user prompt. You give it an idea and it makes something new. It's pretty amazing.
It really is. And conversational AI is a great example of how those different ML types work together for this.
Okay, break that down. How do the three types play into, say, a sophisticated chatbot?
Well, supervised learning gives it that base. It's trained on huge amounts of dialogue data, learning basic sentence structure, common responses to common prompts.
The foundation.
Right. Then unsupervised learning helps it get the subtleties. Understanding slang, or maybe sarcasm, or just the general context of a conversation without being explicitly told, this means that. It finds those linguistic patterns.
Okay, so it gets more natural, less robotic.
Exactly. And then reinforcement learning is crucial for improvement over time.
The trial and error part again.
Yep. It learns from interactions. If you rephrase a question and it finally understands, or if you rate a response as helpful, it gets that feedback, that reward.
So it learns what works in practice.
Right, which helps it have more natural, more effective conversations as it interacts more. It adapts.
Wow, so all three are working together there.
In sophisticated systems, absolutely. And the impact of this generative ability, well, it's huge. It's changing work everywhere.
You see it in marketing, product design.
Engineering, education, R&D, and manufacturing. I mean, it's hard to find an area not being touched by it, which raises a big question.
How can you use this?
Exactly. How can you leverage these capabilities? There's so many possibilities. Think about efficiency gains.
Automating routine stuff.
Or augmenting it, freeing up people for more creative work. Think about personalization.
Tailoring things to individual users or customers.
Right. And maybe the biggest one, better decision-making, sifting through enormous amounts of data to find insights humans just couldn't spot alone.
It's definitely more than just a small step forward. It feels like a real shift.
A fundamental transformation, I'd say, and it's happening now.
Okay, so as we wrap up this deep dive, let's just quickly recap. We started with AI, the big umbrella, computer programs doing smart tasks.
Broad field.
Then we zeroed in on machine learning, that key technique, that subset where programs learn from data instead of just following preset rules.
The learning engine.
And we saw the three main ways they learn. Supervised with labeled data, unsupervised, finding patterns in unlabeled data, and reinforcement through trial and error feedback.
The 3 pillars of ML training.
And all of that laid the groundwork for the creative power of generative AI that we're seeing explode right now.
And looking ahead, that adaptability of ML combined with this creative spark from generative AI,
Yeah.
it's not just about doing old tasks faster.
No, it feels bigger.
It really is. It's about fundamentally changing how we approach problems, how we think about innovation. These aren't just tools. They're becoming catalysts for entirely new ways of thinking and creating.
Yeah, in our jobs and our daily lives even.
Definitely.
And hey, if you want to dig into these ideas a bit more hands-on, there's a great resource we found called Pair Explorables.
Oh, yeah, that's from Google's People Plus AI Research Group. It's excellent.
It really is. They have these interactive articles that make complex AI ideas much easier to grasp. You can play around with concepts related to ML basics, fairness, data privacy.
Risks, benefits. It's a really good way to get a more intuitive feel for it. Highly recommended.
Definitely check that out. So maybe a final thought to leave you with.
Go for it.
Just consider how deeply these technologies are already woven into the systems around us, often invisibly. Now that you understand a bit more about the difference between rules and learning, between analyzing and generating, how might that knowledge empower your next idea?
Or even just help you navigate this rapidly changing, intelligent world a bit more effectively.
Something to think about.